ladies and gentlemen. It is Monday. I am, as you can see, not here, and you are watching these on your Chromebooks. So please turn in your homework from Thursday. Make sure all of your homework thus far, I can't even talk, sorry, thus far is turned in. Today we're going to do the elimination method. Your homework assignment, and you can rewind this back because you won't remember this later, is 146, 22 to 30 all. Let's do some review before we get going on this. Let's review how to do the other two methods. So first, let's look at graphing. So I have the equation 7x plus 2y equals negative 6 and 5x minus 2y equals 6. So step one, if you remember, is to what? Solve for y. So this becomes 2y equals negative 7x minus 6. I divide by 2. Y equals negative 7 over 2x minus 3, because 6 divided by 2 is 3. So if you look down on step 2, m is negative 7 over 2, and b is negative 3. Let's go back over here to the red equation. If I solve this, I get negative 2y equals negative 5x plus 6. Y equals, well, a negative 5 over a negative 2 is going to give me a positive 5 over 2x. And then the positive 6 divided by negative 2 will give me a minus 3. So when I fill in my m and b for that, I get 5 halves and negative 3. So the next step would be to graph these. All right, so let's go ahead and graph this. So in red, since I'm still on red, well, let's go to black and let me put my lines in. All right, so in red, I'm at negative 3, 1, 2, 3, I'm right here. And it says to go up 5, 1, 2, 3, 4, 5 over 2. And then I'm going to draw a straight line. Now I'm going to draw my straight line in a minute. I'm going to put the blue points on first, because I don't have a straight edge like you. Negative 3 is going to be my intercept. Oh, look, they share an intercept. 1, 2, 3, 4, 5, 6, 7. 7's off my graph, over 2. So my blue line, more or less, is coming in like this. My red, with its positive slope, is going up. And you all who used your straight edge can see that they intersected right there. So what does that mean for me? Well, last step is I need to write that point of intersection, which is 0, 1, 2, 3, 0, negative 3. It must be written as an ordered pair. And technically, I really need to check both of these. We have repeatedly said this in class. So I need to take 7x. I need to plug in these points into 7x. So that's going to be 7 times 0 plus 2 times negative 3 equals negative 6. Is that true? Well, that's 0. Right here is 0. So I get negative 6 equals negative 6, and that checks. But we need to do it to the other equation, so that's 5 times 0 minus 2 times negative 3 equals positive 6. Is that true? Well, this once again is 0, and a negative times a negative is a positive, so I get 6 equals 6, and sure enough, it checks. Next, we did substitution. Same equations. Let's see, who do I want to manipulate around? Do I want to solve for the 7, the x here, the 2, the y there, the x here, the y there? It's not going to matter in your world. So let's go for the 2, because at least I know 6 divided by 2 will get me a whole number for part of this. So 2y equals negative 7x minus 6. Y equals negative 7 over 2x minus 3. So here is the stuff that I need to plug in for this y right here. So when I do that, I get 5x minus 2 times the stuff, which was a negative 7 over 2x minus 3. And that needs to equal 6. So 5x minus, well, 2 times this negative 7 over 2 is going to end up being a positive 7x. Negative 2 times this minus 3 is going to be a plus 6 equals 6. 5x and 7x is 12x. Plus 6 equals 6. I subtract 6 from both sides. I get 12x equals 0. I divide, I get x equals 0. I believe that was true when we just finished graphing. So what happens when I take that 0 and plug it back in? Well, I come back over this way, and I end up with y equals negative 7 over 2 times 0 minus 3. Well, negative 7 over 2 times 0 is just 0, so I get y equals negative 3. So when I do all that, and if you notice I didn't follow it within my steps up here, I get an ordered pair of 0, negative 3, which matches what we got on the first slide. So hey, this is all good to go. Because all three different ways, substitution, graphing, and elimination, should all get us the same answer. So let's look at this using elimination. So I have my two equations. I need to look at them. So the first step is to arrange them such that the x's are lined up, the y's are lined up, and they're on the left side of the equal sign, and the numbers are sitting over here on the right side. Step 2 is you have to multiply one or both equation by a number to obtain coefficients with the same number opposite, to obtain the same number. The opposite sign part is not important. We'll talk about that in a little bit. So in the case of these, my y's, both of them have a 2. Life is good for us. We don't have to do step 2. We get to go straight into step 3. Now, because they have the same number in front of them, both have 2's, one is a plus, one is a minus. Because they have opposite signs, I get to add these equations together. So 7 plus 5 is 12x. 2y positive and added to a minus 2y or negative 2y. These got 2y, they cancel. Negative 6 plus 6 is 0. I divide, I get x equals 0. Step 4 says I have to substitute that value, that 0 that we just got, back into one of the equations. It doesn't matter which one. So just because blue is on top, I'm going to plug it back into blue. 7 times 0 is 0, so I have 2y equals negative 6. When I divide that, I get y equals negative 3. Last step, must write as ordered pair, so it's 0, negative 3, which agrees with everything we just got on the first two examples. And I'll review. Let's look at another one. So on this one, they're not even arranged. I have a y sitting here, and then an x, and then I have an x and a y. So first step, I have to rearrange them. So I'm going to end up with negative x plus 2y equals negative 8. And then the red one is written in the correct order, so that's x plus 6y equals negative 16. So I look, do my x's or my y's have the same coefficient, the same number in front of them? And sure enough, when I look at this, I see right there that those x's both have a 1. So what do? I get to look at their signs. Do they have opposite signs or the same sign? Well, one's negative, one's positive, so that says they have opposite signs, so I'm going to add. And when I add these together, the x's drop out, and I end up with 2 plus 6 for 8y equals negative 8 plus negative 16 is negative 24. When I divide by 8, I get y equals negative 3. Now I just have to pick an equation. It doesn't matter which one. I'm going to take the top one. So I get 2 times negative 3 minus x equals negative 8. Negative 6 minus x equals negative 8. I'm going to add 6 to both sides. So negative x equals negative 8 plus 6 is negative 2. Can't have a negative, so I have to divide both sides by a negative 1, and x ends up equaling positive 2. So my answer is 2, negative 3. Awesome, we're doing great. All right, last example. All right, so these we check and we see the x's are lined up, the y's are lined up, the numbers are lined up. So now I look at these two equations and say, do they have the same coefficient? They do not. So what does that mean I need to do? I need to multiply through. I need to decide, am I getting rid of the x's or am I getting rid of the y's? So in the case of this problem, I'm going to choose to get rid of the x's. So to get rid of the x's means I need to multiply the top row by whatever the coefficient is of the bottom row. In this case, it's a 2. So this becomes 2x plus 6y equals 14. My bottom row is 2x minus 4y equals 24. Now, my x's have the same number in front of them, but they have the same sign. And since they have the same sign, we are going to subtract. So 2 minus 2 makes those cancel. 6 minus a negative 4 is really a plus 4. So 6 plus 4 is 10y. 14 minus 24 is going to give me a negative 10 divided by y equals negative 1. Plug it back into either equation. I end up with x equals 10. Answer must be in ordered pair, so this is 10, negative 1. And you are good to go. All right, enjoy your homework.